This mic is live.
Okay. Okay. If I could just have your attention for a moment. Good evening, everyone. You're very welcome to the Dublin Institute for Advanced Studies. I see some familiar faces in the audience, so you were very welcome back after, let's just call it a break of a couple of years, and I'm very delighted also then to see some new faces. Because of course, before COVID, we did have a very active programme of public events at the Institute, and we are beginning to actually build up the programme again. For those of you that don't know me, I'm Eucharia Meehan. I'm the CEO and Registrar of the overall Institute of Advanced Studies. This evening's event, I suppose, has a dual function. It is part of our programme of events in the Festival of History. We have a second event next Monday night in Dunsink Observatory, so you can just check online. I think there may be a few spaces available for that if you're interested in that. It's also an event as part of our 75 years of cosmic physics programme, and specifically related to the observatory and a particular telescope that was set up by Armagh, Dunsink and Harvard, and in fact involved the first cross-border agreement on the foundation of the state between the state and Northern Ireland. So for those of you that might be interested in that, have a look online. So coming back to this evening, as I say, it's a dual function event. My role really is just to welcome you, and I would particularly welcome this evening. I would just like to pick out Jim O'Callaghan TD, who has joined us. So thanks for attending this evening and for taking the time to be here. This, of course, as somebody has reminded me, is the first event that we've had actually for the public since the break and since COVID. So we're very, very happy to be here. A couple of just housekeeping things before we actually get underway. Could I just ask everyone to make sure that they have their phones on silent, if not off completely. I also just need to say to you that if there is, in the unlikely event of an emergency or the fire alarm going off, you exit calmly through those doors and back down the stairs from which you came up, and somebody will be on hand to actually show you the assembly point outside. The facilities, the ladies and gents, are on the ground floor just off from reception where you came in, and the non-binary toilets are actually on the fourth floor. I also need to let you make you aware legally that we actually are filming this evening's proceedings, but the camera is focused on the speaker and on the screen. But you may be picked up voice-wise if you ask questions. So without further ado, again, you're all very welcome, and I'm now going to hand over to Professor Chris Bean, who is the head of Geophysics at DIAS, and he's going to introduce our speaker for this evening, Professor Drury.
Thanks a lot, Eucharia. So I just want to introduce Luke, just going to say a couple of words. So Luke he is a mathematician and works in cosmic physics, as you all know, and he was the head of the Astronomy and Astrophysics section of the school from 1986 until 2018, I think. And Luke has had many awards and distinctions. I'm not going to list them all because you didn't come here just to listen to those, but it started in 1969 when he won the Young Scientist, and he went from strength to strength there.
And now an old scientist.
A funny incident happened when Luke came in 1986. He came to work in DIAS. He had a very distinguished early academic career working in Germany and other places. And when he became senior professor in DIAS, he arrived, and I should say that at the time, the Astronomy and Astrophysics section of our school, Luke might talk in more detail about the details of the school later, shared a building with the section that I'm in Geophysics now. And the senior professor of Geophysics at the time saw him walking around the building and inquired quietly, who is the new student in astronomy and astrophysics? Because he was a sprightly looking 33-year-old or something like that, which was quite an achievement to have to got a position like that at age 33. Says a lot about his early career. Not only did he successfully lead the astronomy and astrophysics section for many, many years, but Luke also has given and still gives great service to the broader community. So he served a term as the president of the Royal Irish Academy. And I think one of his great legacies and practical legacy is that only for Luke, we would not have what we call the Irish Centre for high-end computing. Now, that probably doesn't mean a lot to people who are not in this game, but that's a national computing centre where we have very, very fast computers that can make large calculations, and it's absolutely critical for the research community. Up till very recently, when you turn on your TV in the evening and you look at the weather forecast, the forecast simulations had been run on this machine. We would not have that machine only for Luke. He continues to offer service in open science, and you know, he's very active still in terms of supporting the science community and open science. Open science is a really interesting drive, you know, where everything that's publicly funded research is completely open to everybody. We would think that that's the way it should be, and it is the way it should be, but it isn't the way it has been, just in terms of the way the system is structured. And Luke is really pushing, not just here in Ireland, but internationally, to change that. He has many, many interests, and one of them, of course, not surprisingly, is history. So we're really delighted and privileged to have Luke here with us tonight to take us on a tour through the history of the School of Cosmic Physics here in DIAS. So I hope you enjoy it. Thanks a lot, Luke.
Well, thank you very much, Chris, for that introduction, and rather flattering. I'm afraid it's all been a bit downhill since I joined. Obviously, 75 years is a very long time, and a lot has happened, so I can only cover a few people and highlights. There's a lot more that could be said, but I've tried to concentrate on the more interesting historical aspects of it. So let me start by talking about how did the School of Cosmic Physics come to be? And I think there are really 6 key individuals who, if they hadn't been, we would not have the School of Cosmic Physics, certainly not as it is nowadays. And we start way back in the early 19th century with William Rowan Hamilton. For those of you who don't know him, Hamilton is the greatest mathematician, arguably the greatest physicist that Ireland has produced to date. He was appointed as the 3rd director of Dunsink Observatory and Andrews Professor of Astronomy at a very early age. He was only 22, which beats my 33. And he lived all his life from appointment in 1822 till 65 in Dunsink. And I think without him and his reputation, it's very unlikely that either the Institute for Advanced Studies or the School of Cosmic Physics would have existed, and they certainly wouldn't have existed in the form they are in now. Most people show a portrait of Hamilton in old age, which makes him look like a rather grumpy old man. Personally, I prefer this rather beautiful portrait bust of the young Hamilton, which is now in the possession of the National Gallery of Ireland. It actually came from Ardagh Manor, and it was commissioned by Lord Dunraven, whose son was one of the early pupils of Hamilton. So skipping forward a little bit, the next person who was really very influential in the formation of the school and the institute, in fact, is Edmund Taylor Whitaker. Again, an Andrews Professor of Astronomy, the penultimate Royal Astronomer of Ireland, who spent 6 years in Dunsink. He's actually quite influential. His book, Whitaker and Watson, is still one of the best books on special functions. His History of Theories of the Ether and Electricity is a principal source for early work on electricity. And the key point here is that while he was in Dunsink, I think, he developed an interest in Hamilton's work, and he was one of the first to revive interest in Hamiltonian methods. I was amused to find that he was recorded in 1911 in the census as living in the observatory at Dunsink. Peter might be in, well, Peter's not here, but it's interesting. He's there with his wife, his 4 children, a female English nurse, and 2 Irish housemaids, a housemaid and a cook, presumably all supported on a professor's salary. So things have changed. He's described as having been an inspirational lecturer and teacher, and certainly he does seem to have had a strong influence on one particular young man who at that point was struggling to make a living as a mathematics tutor in Dublin. And this, of course, is Eamon de Valera, who actually attended some of his lectures in Trinity to attempt to improve his mathematical qualifications. And it seems, well, I think it's almost certain actually, that Dev's lifelong fascination with the work of William Rowan Hamilton is due in large part to Edmund Taylor Whittaker's influence. So moving on, we come to a person who's now almost completely forgotten, Edgar Henry Harper. The significance here is that in 1912, there was a reorganization of what were before the Queen's Colleges into the National University of Ireland. And as part of that, a chair of mathematical physics was created in University College Cork. And there were 2 candidates who were both more or less equally ranked, Edgar Harper and Eamon de Valera. The selection committee in the end went for Edgar Harper because he had published a book on aeronautical aircraft design, basically. And Dev at that point only had a past degree in mathematics and no publications. Unfortunately, he was from the north of Ireland, a loyalist, and he signed up in 1916 and was slaughtered like so many others at the Somme. But it's interesting to ask what would have happened if Eamon de Valera had been appointed in Cork. Presumably the whole history of Ireland would have been very different. Fianna Fáil mightn't exist. Sorry, Jim. So actually, Eamon de Valera, instead of becoming a professor in Cork, went on to become a revolutionary, a failed mathematician, and went into politics, where he was very successful, actually. So that's the background to it. And then come 1940, we come to the Second World War, or as we called it in Ireland, the emergency. And Dev does something quite remarkable, actually. He feels, I think, that Ireland has to do something to save intellectual life. He could see what was happening in Germany with the rise of the Nazis and the horrible suppression of intellectual life there. He knew that in Princeton, in America, there was an innovative Institute for Advanced Studies set up by a donation and a philanthropist called Arnold Flexner. And he conceived the idea of setting up a similar institute in Ireland. And I think part of it was certainly a desire to provide a refuge for a few scholars from continental Europe. Part of it was a feeling that Ireland had a strong reputation in mathematical physics, going back to Hamilton, that Celtic studies was also an area of great significance nationally. And so he established the Institute for Advanced Studies in 1940, initially with 2 schools, a School of Theoretical Physics and a School of Celtic Studies. And he recruited actually as the first director of the School of Theoretical Physics Erwin Schrödinger. Now, skipping forward a bit to 1945, where's the point? Here's the pointer, yeah. We come to 2 other significant persons. This is Walter Heitler, who was Schrödinger's assistant, also a very well-known physicist. People still talk about Heitler, Heitler cross-sections. And on the far left, Lajos Yanushi. And I'll explain why they're significant in a few minutes. It's an interesting picture, actually. This is Max Born. This is Monsignor de Bruyn, from Galway, the chairman of council. This is P.A.M. Dirac, the great physicist, and who shared the Nobel Prize with Schrödinger. Dev himself, of course. Conway, who was professor of mathematical physics in UCD and had been tutored in mathematics by Dev, actually, in Blackrock College. Schrödinger, it's interesting, if you look at this, all the men are wearing either ties or clerical collars, except for Schrödinger, who is happily sitting there with an open-necked shirt. So he was ahead of the time. This, I think, is the young A.J. McConnell, and this is Sheila Power, later Sheila Tinney, the first female professor of mathematics in UCD. So why is this significant? Let's move on a bit. Basically, De Valera was thinking at this point of adding an additional school to his institute. Initially, he'd set up just the School of Theoretical Physics and the School of Celtic Studies. And there were a number of reasons why he was motivated to add a School of Cosmic Physics. Firstly, Walter Heitler, whom I pointed out on the previous picture, was working at the time on meson theory, and the experimental data relating to that came entirely at that time from cosmic ray interactions. So Heitler, as an empirically oriented theoretician, wanted to get direct access to experimental data on cosmic rays for his work. Secondly, I'll talk a little bit later about a man called Leo Wenzel Pollock. Pollock had drafted a memo which had been sent to De Valera, arguing strongly that Ireland needed an independent geophysical and meteorological observatory. And finally, of course, Dev himself clearly wanted to preserve the observatory where his mathematical hero Hamilton had lived and worked. So in 1947, as the School of Cosmic Physics was added to the Institute, Dunsink Observatory was purchased from Trinity by the Office of Public Works, and Herman Brook recruited as the first head of astronomy. It should be said that Trinity had, at that point, had essentially did not have the resources to run the observatory. It had been effectively mothballed for about 10 years. And although there was a resident caretaker, the instruments were not being maintained and the buildings were not too bad condition, but it certainly was not in any reasonable condition. Pollock, probably because of his memo, was appointed as the first director and head of geophysics, although actually what he did was we would now call atmospheric physics, meteorology, and climatology. I'll talk a little bit about him later. Interestingly, Heitler, as I said, wanted cosmic ray physics as a key subject to get experimental particle physics data. And in fact, they appointed Lajos Janissy, who had been working with Blackett in Manchester, had published very influential works on cascade development in cosmic ray showers. Interestingly, they wasted about a year trying to recruit Victor Hess, who was the other, at that point, Nobel Prize winning Austrian. Victor Hess had received the Nobel Prize for his discovery of cosmic rays. Had this succeeded, we would have been in the odd position that the two Austrian Nobel Prize winning physicists would have both been working in Dublin. But actually Victor Hess turned down the invitation and they appointed Lajos Janissy instead, which actually I think was a better appointment. So initially, the cosmic ray and geophysics sections were housed in 5 Merrion Square, a building which apparently was personally chosen by De Valera. He had, as part of the treaty negotiations, had secret meetings there, well, supposedly secret, I think in Dublin everybody knew, with General Smuts. So he had a certain affection for the building and it happened to be available, so it was purchased by the OPW for the School of Cosmic Physics. And of course, he had already purchased Dunsink Observatory, which was then to house the astronomy section. You can argue that it was perhaps a bit unfortunate to have the school split over two separate geographical locations. It's now even worse. Geophysics and astrophysics both expanded until really there was no space left in 5 Merrion Square. And so we now are on also in 31 Fitzwilliam Place. So the school is now actually split over 3 geographical locations. I'm sure Eukarya can talk to Jim about this afterwards. So let's look first a little bit about the early history of astronomy in Dunsink. Here's an interesting article in Vistas in Astronomy by Herman Brook and Mary Brook, his second wife, where they make the obvious point, considerations of climatic and other conditions, in other words, the weather is pretty bad in Ireland if you want to do optical astronomy, suggested solar research to be a suitable field of work at the reconstituted observatory. It was decided, therefore, at the time of reopening, that a combined solar telescope and spectroscope should form part of its new equipment. The background to this, of course, is that Brook had worked extensively on stellar spectroscopy in Potsdam before the war, in Cambridge, and also in the Vatican Observatory, and he wanted to continue this work in Dublin with Moira Conway, whom he married following the death of his first wife in Dunsink, actually. Brook was a rather old-fashioned German professor, very straight-laced. He was actually an extreme conservative Roman Catholic. But the aim in the spectroscopic work was to measure the lines in the solar spectrum outside the immediate optical range, going into the near infrared and ultraviolet. So they had to use reflecting optics and reflecting gratings, which is why I think you will still find in Dunsink a number of Rowland gratings. The data that they collected over those years were fed into the revised Rowland tables of solar spectral features. So in a sense, this was also a very early form of open science. Solar physics then in Dunsink continued under Brook's successor, Ellison, and is now again a major focus of research at Dunsink under Peter Gallagher. Here's Brook on the roof of the observatory with the heliostat which reflected sunlight into his solar telescope. He was quite brutal, actually. He ripped out all the old instruments and installed new instruments in a way that you would not be allowed to do nowadays. But really the big innovation from reopening Dunsink, and this has already been touched on briefly by Eukarya, the really big innovation, and I think a triumph of what we now call science diplomacy, was the Armagh-Dunsink-Harvard telescope. And Brook himself, in an early report, noted that while observational work at Dunsink is to be devoted mainly to solar research, the observatory will be able to extend its activities to the field of stellar astronomy through its cooperation with the Armagh and Harvard observatories and its share in the projected Armagh-Dunsink-Harvard telescope. Observations of the greatest interest for studies of galactic study may be expected, which at the same time will represent a symbol of that cooperation which one would hope to see established in wider fields. A sentiment, I think, which we could all share nowadays. And indeed, as Eukarya said, this was the first international agreement between Stormont and Dublin. Lindsay, who was head of Armagh Observatory, seems to have been a very skillful politician, and he played the northern government off against the southern government. He went to the northern government and said, Dev has promised me this, can you match it, etc. So he managed to get a good deal out of it. And this was really, I think, one of the very first examples of a shared international research infrastructure, way ahead of its time and innovative. Sorry, did I skip over? Yeah. So there is a picture of the ADH telescope installed in Bloemfontein in South Africa. There's a separate talk about this coming out up in Dunsink if you want more details. You can see, I think, that certainly if you've had any experience in astronomy, looking at this, you'll say, well, the mounting looks a little bit flimsy for a telescope of this size. And that was certainly one of the problems with it. It's a besetting problem. Donors want to put all the money into getting a large telescope, but what you actually have to do is put money also into things like the mount and the housing. This is not a proper dome, it's a slide-off roof. And there were problems from day one with thermal stability of the instrument. But that being said, it was an excellent observing location. South Africa, basically anywhere in southern Africa, is very good for galactic astronomy because the center of our galaxy passes more or less directly overhead. You also have access to the large and small Magellanic Clouds, which are the two nearest satellite galaxies to ours. So there was good work done in the early days, but politically, obviously working in South Africa became increasingly problematic as during the 60s and 70s, the general revulsion at the apartheid regime was growing. Some of you may remember the Dunn Stores workers and the oranges. So it became really impossible to continue with this. Also, I think it's fair to say that the American side lost interest a bit in the facility. It was regarded as not a terribly useful observation telescope. So basically it fell into abeyance, and Patrick Wayman then managed to negotiate the so-called La Palma Agreement, which got access to telescopes located in the northern hemisphere in the Canary Islands. This was actually a trilateral agreement between the Irish, the Netherlands, and the British. But that also faded out, and eventually, after a long campaign of lobbying, initiated by Evert Moors, carried on by others, finally we now have membership of the European Southern Observatory, which is actually by far the best ground-based observing facility in the world. But I think you can see that there's a trajectory here, and really the Ahmad Dunsink Harvard telescope and the role of the school in helping to set it up really was instrumental in showing that observational astronomy could be done from Ireland, but you had to have access to shared international facilities. Interesting that was part of the advice that Edmund Taylor Whittaker gave to DEV. He said, you know, it will be very difficult to reopen Dunsink as an optical observatory nowadays. You should open it as a geophysical observatory. But of course, the way around that is to do the observing elsewhere. Oops, right. This is going too fast. So just here are the European Southern Observatory's very large telescopes. There are 4 of them in Chile on the Mount Paranal. In the next few years, this will be supplanted by the extremely large telescope. The European Southern Observatory is not very inventive in naming its instruments. Oops. Sorry, this is too sensitive. There are other international shared facilities. I'll say a little bit about this later, but we also have, through Peter Gallagher, membership of the LOFAR Consortium, which is a radio astronomy consortium. So there's an international LOFAR telescope, which is spread across Europe from Poland in the far east to Burr in Ireland in the far west. It's quite important actually to have a long baseline in the east-west direction for technical reasons. And we're back again actually in Southern Africa. We're part of the HES consortium, which operates imaging Cherenkov telescopes in Namibia. So let's turn back a bit to Leo Wenzel Pollock. Here's a portrait of him in his formal academic dress as professor in the German University Prague and director of its geophysical observatory before the Second World War. His grandfather was a Jewish rabbi, and he could see what was happening, and he left Czechoslovakia, Prague, before the war started to seek refuge, initially in the UK. And he was fortunate enough to be recruited by the newly established Irish Meteorological Service from 1939 to 47. He worked initially at Foynes in the Shannon Estuary. It's hard to believe nowadays, but everyone thought back then that the future of transatlantic air flight would be flying boats. And they would land on the Shannon Estuary, which is a natural, if you have a big flying boat, then the Shannon Estuary is a rather good place to land. And if you want a short crossing across the Atlantic, then Newfoundland to Ireland is the shortest route. So the Irish Meteorological Service was initially set up in Foynes to provide weather forecasts for international aviation. But it also, of course, did the rest of the weather forecasting services. And actually, Pollock seems to have been one of the key people in training up the staff, and his reputation for efficiency and punctiliousness rapidly established the Irish Meteorological Service as an internationally respected meteorological service. It's actually rather important because if you think about it, the weather comes from the west. So if you want to predict weather in the UK or in continental Europe, you need to know what's happening in the systems coming in off the Atlantic. So having good, reliable observations in the west of Ireland is still important. So he had worked in, as I said, in Prague as a climatologist and atmospheric scientist before World War II. An interesting aspect of it is that he was one of the very first to introduce the idea of using punched cards and the automatic tabulating machines, precursors of modern computers, to collect and analyze weather data. So in some circles, he's now seen as an early pioneer of big data. As I said, he was forced to leave Prague, started working at Foynes, and then later in Dublin, before being appointed as first director of the school. There was a strong personality clash here with Bruck, who was an old-fashioned German professor and insisted that he was director of the observatory and there was not any other director above him. But De Valera persuaded Bruck that he could be director of the observatory and Pollock would be director of the school and it would be primus inter pares. And Dev, I think, correctly seems to have identified in Pollock a very able administrator as well as a good scientist. He was dedicated to collecting lots and lots of precise measurements. He was very careful with his figures, and he supervised all the work of reconstructing 5 Merrion Square into a home for the geophysics and cosmic ray sections. And actually, I've seen some of the early OPW drawings, which are annotated by Pollock in German. So one of the things he's responsible for, if you ever look at 5 Merrion Square, you'll notice that it's the only Georgian house which has a meteorological observing tower sticking up from it, something that you would never be allowed to do nowadays. Ironically, the way the protected structures law works, actually this eyesore is now also protected. Oops, yeah. Okay, Pollock's main work in Dublin was actually on atmospheric aerosols, or what were then called condensation nuclei, where he did a lot of groundbreaking work with the Nolan brothers in UCD. This is actually very important nowadays because still the formation of clouds and how water vapor condenses is one of the big uncertainties in all climate models. And so understanding the abundance of nuclei on which cloud droplets can form is important. And together with the Nolan brothers, they made major instrumental advances in the field. There's the Pollock-Nolan absolute condensation nuclei counter is still in use as a reference instrument. And I have to say that a large part of this was due to the skill and ingenuity of a man called Jeremiah Daly, whom Pollock recruited. There's an interesting story to this. Jerry, as everyone called him, had no formal education, left school early, and Pollock found him working in Dixon and Hempstead, where during the Second World War, because there was a shortage of spectacle lenses, he'd actually built a lens grinding machine for Dixon and Hempstead, which worked very well. And Pollock was so impressed that he recruited him as the mechanical and experimental officer, who then helped design some of these instruments. And I think it's fair to say that Jerry never really got the credit he deserved for some of that. This early work on atmospheric nuclei and condensation lives on actually now with the Mace Head station operated by Galway. One of the students, some of the students who worked with the Nolan brothers and Pollock went on to work to get employment in Galway and continued this work and helped set up the Mace Head station. So here is Mace Head nowadays, and you can make a direct connection between this and the early work of Pollock in Berrien Square. It wasn't, however, just atmospheric physics. Pollock was interested in a whole range of areas, including more general geophysics, and he hired a young geophysicist, Tom Murphy, in 1952 to carry out gravity measurements across the island. It is a tribute to Pollock's administrative and political ability that he persuaded Guinnesses to actually donate a van to the section, which was used then to carry instruments all over the country. And Tom Murphy basically went all across the country, making point measurements of the strength of gravity. One of the jokes in later life was that if you wanted to know where to get a good pub meal, you just had to ask Tom Murphy. He knew all the pubs in Ireland that gave you good food. And in fact, he's the man actually who said, "Who's the young student in Sheen?" So this was basically Tom Murphy's life work. He was still working on it when he died in 2003. And this is still a valuable data set. Nowadays, of course, a lot of it can be done from satellite observations, but you still need ground truth measurements. And the data is of considerable commercial value and has been licensed to mineral companies, but is freely available. As Chris was saying, this is open science. If it's for bona fide academic research, we'll happily share it with you. If you're going to make money out of it, we'd like a little bit of it back, please. Yeah. Here is the gravity survey that they produced. I think what's really quite remarkable is the gradient across Dublin, which is related to the fact that the Wicklow granite is actually quite light. I think that's right, isn't it, Chris? That's correct. Yeah. So the joke I like to make is that you can actually lose weight without losing any mass if you go from the north side of Dublin to the south side of Dublin. It's a trivial effect, but without changing anything, if you just go from north to south, you will be a little bit lighter because gravity is not quite as strong. But the other main method, of course, for probing the deep structures of the Earth, and in fact by far the best really, are so-called seismic surveys based on either earthquakes or artificially produced seismic waves. And so the propagation and reflection of elastic waves, so-called seismology, is really probably the cornerstone of deep structural studies of the Earth. It can be complemented with things like magnetic fields and gravity fields, but really the best tool for studying what's going on deep underground is to use seismology. And the era of modern seismic studies in Ireland began under another professor in the geophysics section, Brian Jacob, who was a world-leading expert in controlled source seismology. If you want to set off an explosion to produce seismic waves, it actually works very well if you do the explosion underwater. It's a sort of impedance matching thing. You get much more buck for your bang, so to speak. And Brian was an expert in this, and I think he took a sort of childish delight in setting off explosions, which was quite fun to watch, actually. His greatest regret was that towards the end of his life, he had a wonderful project where he was going to explode a very large explosion off the sea in the North Atlantic off Portugal. The seismic waves would go right through the Earth, probe the core mantle boundary, and be picked up in New Zealand. And unfortunately, because of political opposition in Portugal, the thing had to be cancelled. And there was a period when the Institute owned a ton of high explosive. I don't quite know what happened to it. You can't remember. You don't want to know. No? But anyway, he also set up a network of seismic monitoring stations, which have been upgraded and improved since then. And they now continue as the Irish National Seismic Network, which we now run in cooperation with the Geological Survey. So that's sort of classical seismology. A more interesting modern take on it is actually the activity of Chris Bean, who's applying these techniques to the study of volcanoes. And Chris is the expert here, so I'm not going to embarrass myself by trying to describe it. But I think this has major implications for hazard mitigation in active volcanic regions. It doesn't really apply in Ireland, but if you live in Naples, it's very important. And of course, there is an interesting political spin-off, which is nuclear non-proliferation, which is a key foreign affairs interest of Ireland, has been for a very long time. And basically, the key to nuclear non-proliferation treaties is to prove that seismology can pick up unauthorized nuclear tests. So there's a global network of seismic stations monitoring for nuclear blasts. Ireland is a strong supporter of the Comprehensive Test Ban Treaty Organization, and we actually host the National Data Center for the Comprehensive Test Ban Treaty Organization. I never get that right, with some limited support from the Department of Foreign Affairs. However, you can probably the biggest and most significant discovery that geophysics made actually was that, in a sense, Ireland is bigger than we used to think. And the key point here is that shortly after I joined the Institute, Brian Jacob was doing some early EU proposals together with the University of Hamburg to look at the formation of the North Atlantic, how exactly the North Atlantic is actually expanding at about a centimeter a year, is it? Yeah. And so it's gradually stretching out. And these early seismic studies using underwater source experiments, where Brian was the expert, made the rather surprising discovery that the continental shelf around Ireland actually stretches much further out into the Atlantic than was previously thought. In particular, the Rockall Trough region, which people used to think was oceanic basin, turns out to be stretched continental shelf. It's thinned out by stretching, but it's definitely still continental. And as the Marine Institute keeps telling us, this has very significant economic implications under the law of the sea. Oh, sorry. Yeah, go back, there we are. So if you go to the Marine Institute website, they're very fond of talking about what they call the real map of Ireland, which shows our zone of economic interest, which goes, and this bit here, if the Rockall Trough had been oceanic, then basically the line would have come down here, but as it is, we go all the way out there. So it's quite significant in terms of economic exploitation potential. Let me turn now to cosmic ray physics. As I said, this was one of the main motivations for setting up the Institute in '47, because Heitler wanted particle physics data, and the only way you could get it at the time was by studying the interactions of cosmic rays in the atmosphere. So they employed Lajos Janissy. Actually, this was a much better hire, in my view, than Victor Hess would have been. Janissy was a very able experimenter and also a good theorist. Some of his work on cascade development anticipated Feynman scaling, and he attracted really a lot of very good researchers and rapidly built up a distinguished group. People like Harry Messel, who went on to become a doyen of physics in Australia, for example, worked there. However, in 1950, he went on holiday, leaving a sealed letter behind. I think he was hedging his bets a bit. He never came back, and when the letter was opened, it turned out to be his letter of resignation. So I think he was hedging his bets. If things hadn't worked out in Hungary, he would have come back and said, please give me my sealed letter, and torn it up. But instead, he went back to Hungary, and he ended up as director of the Central Research Institute for Physics in the Buda Hills outside, just to the north of Budapest. I actually visited there many years ago and had the pleasure of meeting one of his sons, who remembered with pleasure holidays in the west of Ireland. So he was then succeeded by Cormac O'Kelly, who was my predecessor. In many ways, it's not too surprising that he returned to Hungary, because he was the adopted son of the philosopher George Lukács, who had come back from exile in Moscow to Hungary and could basically promise him political support in Hungary. Interestingly, when he did go back, there doesn't seem to be much secret really about his departure, because he literally took the kitchen sink. According to Jerry Daly, Jerry said that Jánosi asked him to come out to Sandymount and disconnect the kitchen sink so that he could take it to Hungary with him. So, quite extraordinary. So initially, of course, the cosmic ray section was there to do experimental particle physics. But as you moved into the late 50s, early 60s, then basically experimental particle physics moved more towards ground-based accelerators. CERN was set up. Particle physicists lost interest in cosmic rays because you couldn't control the beam. It was, if you wanted to make precise measurements, it's very much easier if you have a beam of particles of a fixed energy and you know exactly what they are. So basically, particle physics transferred from cosmic ray physics into terrestrial accelerator physics. That's actually now changing a bit, because there are limits to how high you can get with terrestrial accelerators. Cosmic ray physics still probes a region in energy space way beyond anything that CERN can reach, even today. And there is a revival of interest now in cosmic ray physics as a source of particle physics data. But certainly for 30, 40 years or so, cosmic ray physics was regarded by particle physicists as a bit of a passé subject. The DIAS group did actually make part of this transition. They collaborated with UCD on a number of nuclear emulsion experiments at CERN. This was using techniques which had been developed in cosmic ray physics, using so-called nuclear emulsions and scanning. I see one former scanner here in the audience. But again, as science moved on, CERN turned more and more to electronic detectors. To build electronic detectors, you need large resources, you need good electronic laboratories, it's expensive. And so the DIAS group then turned more back to their original starting point, to studying the origin and composition of the cosmic rays as a problem in astrophysics. So not really to try and work out what the particles were doing when they came into the atmosphere, but to see where they were coming from and what they were made of. And obviously, if you want to do that, you have to go as high as you can. So a lot of work with balloons, but even better is to go above the atmosphere into space. And this is the start of Ireland's space research. So building on the expertise in scanning nuclear emulsions, and a chance meeting between Cormac O'Kelly and Buford Price at the Tata Institute in India, the group then came to specialize in the use of what are called solid-state nuclear track detectors. These are basically just stacks of sheets of plastic. The advantages are that this is a very cheap technique. Plastic isn't very expensive. It's very light, which is important if you want to go on a balloon or into space. The downside of it is that getting the data out afterwards involves very complicated chemical etching. There's quite a lot of black art there, laborious manual measuring under microscopes, and I think Eileen can testify that that was very laborious. But because Dennis O'Sullivan and Alex Thompson were experts in this field and were working on it, Dennis O'Sullivan had the good fortune to be on sabbatical with Buford Price in California in 1970, and he got the chance to work on some of the very first lunar samples brought back from Apollo 11. And this then resulted in an opportunity to fly small detector stacks on Apollo 16 and 17, which were exposed on the lunar surface before being returned to California and Dublin for analysis. And Dennis, a few years ago, donated some of this material to the National Museum of Ireland. Oops, sorry. So, yeah. So building on that, part of the process of Ireland joining the European Space Agency was the opportunity to collaborate with the European Space Agency's Science and Technology Centre in Estec in Holland. And Alex, Dennis, and Cormac Kelly collaborated with Estec to build what was called the ultra-heavy cosmic ray experiment. It's not that the experiment was ultra-heavy, but it was looking for ultra-heavy nuclei in the cosmic rays. And this was an experiment designed to fly on what was called NASA's Long Duration Exposure Facility. This was going to be basically just a passive cylinder, which was thrown off the space shuttle and retrieved and brought back to Earth 6 months after being deployed. But it actually turned out to be an extremely long duration because after deployment, we had the Challenger disaster. The shuttle launches were stopped for about 5 years. And so the long duration exposure facility, which was meant to be exposed for 6 months, actually ended up being exposed for 6 years. It was retrieved at the very last minute before it would have come back into the atmosphere. So here is the LDEF being deployed from the space shuttle. And these panels here with the Mylar thermal blankets are some of the DIAS Estec experiments. There were actually 16 trays, each containing 3 large cylinders. The cylinders were aluminium cylinders about this high, with 4 detector stacks in each cylinder. And it's quite phenomenal, actually. The total exposure was 170 meters squared steradian years. Out of that, we saw a grand total of about 35 actinides. That's nuclei, thorium, uranium, and heavier. And this is to date by far the best sample of actinides in the cosmic rays. O'Kelly is commemorated by the O'Kelly Medal, which the Institute donates every 2 years at the International Astroparticle Physics Conference for fundamental work in cosmic ray physics, astroparticle physics. I persuaded O'Kelly's estate to fund the design of the medal and buy the medals and present them. So it's a nice little way of commemorating him. So that was the start of Ireland getting into space. It led to other developments. Alex and Dennis were invited to take part with Susan McKenna-Lawler in Maynooth in the Giotto mission to Comet Halley, and the Phobos missions to Mars. We also collaborated with the Max Planck Institute for Astronomy on the ISOPHOT instrument doing infrared astronomy. Brendan Jordan in Dunsink collaborated with UCD to build the optical monitoring camera for the Integral mission. And of course, this is all culminated now with participation in the mid-infrared instrument on the James Webb Space Telescope, where Tom Ray, current director of the school, is a co-principal investigator. Tom is also a co-PI on the Ariel mission to look at exoplanets. So here's, just as an illustration, is the filter wheel of the MIRI instrument on the James Webb Space Telescope. If you've seen these things, you can actually see that this is a direct descendant in some ways of the filter wheel on Isofort. And DIAS provided some of the filters, and we wrote software for the instrument. So is Paddy here? Paddy Kavanagh is the expert on all this. Yeah. So what we see really is that whereas these were originally quite distinct sections of the Institute, cosmic ray physics and astronomy really have converged into modern astrophysics, astroparticle physics. And the last decade really has seen, well, last 2 decades, have seen a remarkable revival of interest in astroparticle physics. It's quite remarkable really that the key open questions in theoretical physics at the moment are all based on observations coming from astronomy. So neutrino astronomy has revealed that the neutrinos are extremely light but not massless, something we don't really understand. We have seen the development recently of gravitational wave astronomy with some high energy counterparts. And Felix Aharonian, my colleague in DIAS, is now actually one of the world leading authorities in this interesting field of what is called multi-messenger astronomy. I mentioned earlier the HESS telescopes, also the neutrino telescope KM3net, the LASSO high altitude observatory in Tibet. We're involved with all of these. And so the former, what used to be quite distinct astronomy and cosmic ray sections are effectively now a single astronomy and astrophysics unit. Chris mentioned computing. The School of Cosmic Physics, because we are involved in collecting large data sets, has always been interested in computing and data reduction. And in fact, you could, even if you wanted to, push this back and say Pollock's very early work before he joined the Institute using punched cards was a forerunner of this. So there is a rather good site on the history of computing in Ireland. And rather remarkably, it turns out that the first modern electronic computer in Ireland was purchased by the then Irish Sugar Company in Thurles from the British Tabulating Machine Company. So there's a record actually of physicists from the School of Cosmic Physics trying it out in 1959. And what it says is cosmic physicists from the Dublin Institute, it should be for advanced studies, not of, visited Thurles to evaluate the suitability of the British tabulating machine computer for their research. They succeeded in fitting experimental results to a theoretical curve, but it was far too labor intensive, and they decided it wasn't, at that point, it was not a practical proposition. Moving on a bit, UCD and both UCD and TCD acquired IBM 1620 computers in the early 60s. The machine in Trinity was transferred to Dunsink in 1967 and was used there until 1974. And actually, I remember seeing it on a student visit to Dunsink as an undergraduate. It was then moved to Dundalk, as it then was, Regional Technical College, and unfortunately, there's no trace of its whereabouts now. Chris will remember that Geophysics had a series of data general mini computers. You probably remember the Nova and the Eclipse. We also had an early Sun workstation, and for the work on Isofort, a DEC Microvax. But really, the most significant development perhaps was that in 1996, it became possible to do high-performance computing, not by buying expensive mini-computers or mainframes, but actually by taking commodity PCs and connecting them together. These were the so-called Beowulf clusters at the time. We built the first one in 1996 and started to work on parallel code development. Ultimately, this then led to the Cosmogrid proposal to PRTLI, which Eukarya will remember, I'm sure. Yes, on the other side of the table. And eventually the formation of the Irish Centre for High-End Computing, which I'm glad to say is still going strong today. Yeah. So I think you can see that there's a common theme coming through here, which is that if you want to do advanced research, and we are an institute for advanced studies, it generates a demand for advanced infrastructures. You can't do advanced research without access to the necessary enabling advanced infrastructures to do that work. So we were early pioneers in the use of shared optical observatories, starting with the ADH, leading on to the European Southern Observatory. You could, if you wanted to, say that the Macehead Atmospheric Monitoring Site is also an example of an infrastructure generated out of our research interests. We've been involved in many joint space missions, from the Ultra Heavy Cosmic Ray Experiment now to the James Webb Space Telescope. Again, advanced infrastructures done in cooperation with international partners. Nationally, we have the National Seismic Network and the CTBTO Data Center. We have the Irish Centre for High-End Computing, which then got Ireland into the Partnership for Advanced Computing in Europe, and now into the joint undertaking Euro-HPC, which is the future of high-performance computing in Europe. A slightly odd one is a follow-on PRTNI proposal, e-INIS, included a federated identity service as a pilot project under HEANet. That turned out to be enormously successful. And Owen Kenny in HEANet has assured me that the Edugate facility, which they now operate, is one of their most popular product offerings and would not have happened if the Institute hadn't funded the pilot. I mentioned ILOFA, which is an international European collaboration in low-frequency radio astronomy. And of course, we are participants in various high-energy and astroparticle experiments, the high-energy stereo system in Namibia, KM3net, LASSO, etc. So how much infinite? Oh, not too bad. So I'm winding up now. What you can also see is that various different areas of research have waxed and waned over the years in the school. So I think one of the strengths of the school has been that it has been prepared to drop fields and move into new fields when it seems appropriate. So solar physics, we began doing a lot of work in solar physics. It sort of faded out under Patrick Wayman, but has come roaring back now with Peter Gallagher. Atmospheric physics, we started, the universities began to work on it. It moved out into the universities, replaced by solid earth geophysics under Tom Murphy, Brian Jacob, Chris Bean. Stellar physics has always been an interest of the school, but is now a really important major activity under Tom Ray, who specializes in star formation and outflows from young stars. And now, of course, this also involves exoplanet work. Cosmic ray physics sort of morphed into high-energy astrophysics under Cormac O'Kelly and myself, and is now, as I say, really a key component of modern physics in that it provides the problems which theoretical physics is trying to solve. And I'm delighted to say we have a new area, which is heliospheric physics, the interaction of the solar wind with planets. And there, Katrina Jackman, the first female professor in the Institute, actually is heading that work. It's invidious to pick out a few contributions over the years, but if I wanted to just illustrate with a few random things, I think we could mention the first observation by Tom Ray's group of rotation in stellar jets. It's a rather surprising observation by Emma Whelan, again in Tom Ray's group, of jets from brown dwarfs. Emma is now a professor in Maynooth. One of the consequences of the UHCRE was that I got very interested in the chemical composition of cosmic rays. Exactly why are the different nuclei in the cosmic rays, why do they have the relative abundances that they have? And I believe that this is actually linked to interstellar dust composition. And I think, well, it's my theory, so I can say it, but I think the best theory for the composition of the cosmic rays relates it to sputtering of interstellar dust. One of the more exciting results from the HESS telescopes was confirmation that one really does see high energy gamma rays resulting from particle acceleration in supernova remnants. But as so often in science, it turns out that nature is more complicated than we thought. The origin of the really high energy particles remains something of a mystery. I've mentioned the continental nature of the sediments under the Rockall Trough. Chris Bean, if you're interested, can explain to you his new interpretation of seismic signals from volcanoes, which I think throws out a lot of earlier work. Computational studies, Jonathan Mackey has done really very good work on photoionization regions and the interaction of winds from hot young massive stars. And as a slightly curious, just random contribution, you may remember that early on in the first lockdown on RTE News, there was a mention that the seismic noise background from traffic had dramatically reduced. And that, of course, was a side product of the National Seismic Network. So here's a collage of some illustrations from this. Emma Whelan's, this is an artist's impression, but Emma Whelan's discovery of a jet from a brown dwarf made it onto an Irish postage stamp. This, I think, is the prettiest picture I've ever seen. This is the HESS image, the first HESS image to resolve a supernova remnant in gamma rays and show what we had theoretically predicted but never seen before, this glowing ring of gamma ray emission. This is some data from the National Seismic Network. Ireland is actually incredibly quiet seismically, but there is some activity. There is a fault line running from across from Wales down here through Council Point. Interestingly, where the ESB wanted to build a nuclear power station, so they actually paid us to do seismic monitoring on Council Point, and it turns out to be the most seismically active place in Ireland. I mean, it's trivial activity, but it's the other place where you do get some activity is in Donegal. So if you want to actually feel an earthquake in Ireland, you have to either go to the southeast or the northwest. Midlands, forget it. This is the Apollo 16 land. This is the leg of the landing, and you can't really see it, but this is the DIAS cosmic ray experiment attached to the landing leg of Apollo 16. This is the Hubble image of the so-called pillars of creation, which Jonathan Mackey's computational code explains. And here's, as I say, we're now working a lot on volcanology. So here's a volcanic crater on the Sierra Negra. So to summarize, the School of Cosmic Physics is now much more diverse, much more active and larger than at any time in its 75-year history to date. I think I've tried to show you that as well as making major scientific discoveries, we have been a significant instigator and facilitator of both national and international research infrastructures. I think that's a very important role of the Institute. We have trained numerous students in what the Act rather coyly calls methods of advanced research. And as we were discussing this morning, this is a significant contribution to the, well, what people rather unfortunately sometimes call human capital. But effectively, if we want to continue to be a successful country, we have to have people who can understand data, who can work with noisy data, who are computer literate and can ask difficult questions and solve difficult problems. So, in conclusion, I think I have to say it's been a great privilege for me to be part of this history. I was rather embarrassed to discover it's now for 36 years, and it only remains for me to wish the school well, and I'm sure it has a bright future. So I'll be happy to take questions. Thank you.
Thank you very much, Luke, for a deep and riveting journey through the school. Absolutely fascinating. two things strike me before we ask questions. One is you've just discovered a new way for DIAS to open up a new channels in the fit area of fitness, where you can lose weight without doing any work, just by going on a relaxing walk.
Yeah,
as
but
the
you don't lose
changing
any
the
mass.
exactly. But that's people are standing on the scales. And the other thing that strikes me is the serendipity associated with a lot of what you've shown as a bottom-up research organization where it's principal investigator, researcher-led. Random things happen, you bump into people, you follow random pathways, and you can see it leads to a great diversity of activity. So it's a very interesting journey. So as Luke is happy to take questions, so if anybody has some questions, I think Dimitri has a microphone. Please just indicate if you'd like to ask a question.
And I apologize for running 10 minutes over.
Let's get back to this subject of early weather forecasting. Exactly where do they do the weather forecast now in Ireland? Is it still actually based in Ireland? Or I know the Geophysical Organization was part of the consortium involving other European geological offices. We were supposed to come up with a common model, but do we actually control, or do we even control our own weather forecast anymore in this country?
Well, yes and no. I mean, we're part of the European Consortium for Medium-Range Weather Forecasting. The codes, the iCheck scientists have made major contributions to writing those codes. We know what is in the codes. If we wanted to, we could run our own models, but it's actually more efficient to just use the shared European model. But we know perfectly well what's going into the models. We know how the models work, and I think.
So essentially, it's a pan-European job where one model is run on the one supercomputer.
Well, it's not. Yeah. Well, it's not. They actually run several instances of the model. It's not just one model. They run an ensemble. This is ensemble forecasting. You run several models with slightly different initial conditions, and that gives you a much better handle on the statistics of what's likely to happen and what is unlikely to happen. But as I say, I mean, it's a lot of work, and it makes sense to share it with others because the weather affects everybody. The weather forecasts are actually pretty accurate nowadays. Yeah.
Just on
that in the end, all of that information, that area, and it then from which is the forecast from that information.
Yeah,
they're the local expertise.
Yeah, I mean, if you want to go downscale to what's happening locally, then you need to know things like the local orography and things like that. And that, of course, is local expertise. But the global parameters come from the European models and increasingly now from satellite observations. I mean, what has really changed weather forecasting is the availability of satellite data, particularly over things like the Atlantic.
And I guess no model is perfect. They all have their idiosyncrasies, and local knowledge in terms of the interpretation does definitely come into play. I think Aoife was next with her hand.
Thanks, it was a great talk. Thanks for that. Just looking at the slide, and actually I hadn't realised that DIAS were involved in so many, or certainly in kind of instigating so many projects that led to research infrastructures. And with the Geological Survey, so we're familiar with the National Seismic Network, and the partnership for that works really well between us and the expertise coming from DIAS and the support for running the network. But how do you see the future of research infrastructures in Ireland? What do you think we need to do to make sure that those infrastructures are properly supported and run, and that the partnerships are right? And how can we improve that so that we have more of those kind of shared services?
That's an excellent question. What we need actually is a proper funding line for infrastructure. I mean, to some extent, PRT&I did that, but it had the big problem that it was 5-year chunks. What you need is a funding system which gives rolling grants so that as long as an infrastructure can demonstrate that it is providing a useful and needed service, it will get regular tranches of funding. Now, I don't think anyone nowadays would fund a project indefinitely with no sunset clauses in it. They did, interestingly, in the 18th century, If you look at the Act of the Irish Parliament establishing Armagh Observatory, it is an act to establish an observatory in Armagh forever. I mean, you would never get away with that nowadays. But it is a problem. I mean, we had this problem with iCheck, that you get 5 years funding, and then you have to reapply and pretend you're doing something slightly different to get another 5 years, and so on and so on. So really what we need is a dedicated funding program for research infrastructures with the possibility of rolling grants. But Eucharia is the expert here, so.
And with that, it's Eucharia's turn to ask a question.
Yep.
Luke, can I just ask you about the Webb Space Telescope, the James Webb Space Telescope? You obviously showed us the picture of the work and sensors and detectors that DIAS had done for the Mary component, and just to say to people, there's 4 instruments on the Webb Space Telescope, and obviously DIAS was involved in the design of one of them. And I will also just get the plug in to say that DIAS is the only Irish research group involved in the Webb Space Telescope initiative, which is obviously a massive global project, that telescope being the successor to the Hubble telescope. But can you say just a little bit about what actually is expected to emerge from that massive global investment in that telescope? What do we hope to learn?
Well, the big thing about the James Webb Space Telescope is that it works in the infrared, and it's big. It's incredibly big, actually. I never thought that those mirrors would all fold out and work properly, but it's worked spectacularly well. It's a big telescope, and it works in the infrared, and that's important because if you want to look far back in time to the early universe, to the time when galaxies were beginning to form, that light has been redshifted from the visible down into the infrared. So you have to really look in the infrared if you want to study the first stages of galaxy formation, the very first generation of stars. And there are unsolved problems there as to how did the very first generation of stars actually form? What did they look like? One of the slight mysteries is heavy elements seem to be formed very early on. Why is there so much iron in the intergalactic medium at early times? And also we have a big puzzle actually with the supermassive black holes, which LIGO is beginning to detect. We don't really understand how they formed in the numbers that seem to be there so early on. And the only way to do that is to look way back in time. And to do that, you have to go into the infrared, and you need a big telescope, a really big telescope. Over there.
There seems to be a commercial imperative to third level sphere separate from DIAS, but do you think, has that ever impinged, or has that ever been something that DIAS has suffered from?
Well, I mean, this is a debate that you could have forever, really. I mean, it's quite clear, DIAS is here to do fundamental basic research, and I would argue very strongly that if you don't do that, then you simply don't have the basis on which you can build any decent applied research. Also, the sort of training you get when you work on these really difficult basic problems is actually highly transferable. As I said, if you can analyze geophysical or astrophysical data sets which are noisy, incomplete, difficult, then you can do any data analytics work in industry. And a lot of our students have actually gone on to jobs doing data analysis in industry. Some of the work, of course, does have direct applications. I mean, some of the detector technology can be transferred immediately. But I think the more important thing is we produce highly skilled people who are used to working on difficult problems. And that would be my argument. Yeah.
Thank you. Just one last question then about the early people who came from fleeing persecution, or the European scientists who came over to DIAS at the initial stages. Did they feel, do you know, in any way that they were limited by the funding that might have been available at the time?
No, at that time they didn't. I mean, it was actually pretty generous. I mean, when you consider that most of the rest of Europe was in chaos, and certainly if you remember that picture I showed of the Theoretical Physics Symposium in '45, remember that at that point, the UK had severe rationing. One of the reasons they liked to come to the symposium in Ireland was that there was plenty of food. And in terms of resources, at that point, I think we would have been competitive with most other major research institutions. Now, where we fell behind was in the 60s and 70s, where you really needed big investment in electronic technology and computers. But we managed to get around that by sharing resources and setting up things like the Irish Centre. So, in a way, being under-resourced forces you to be creative. So we're certainly not awash with money. God help, no. But we do remarkably well with what little we do have. So I hope that answers the question. Yeah.
So I'm going to take a couple more questions and we'll finish in under 5 minutes, I think. I'll just make a comment on that last question.
Yeah.
It's a very interesting question because we had the Director General of SFI with us, all the Science Foundation Ireland this morning, and we were talking about exactly the same questions. Yeah. In terms of the overall funding landscape and its direction. So it was a very interesting question.
Just a question to follow on from that. What is your success rate on European grant applications and European funding? And just as an aside, does not being a member of CERN have an effect on your application to get a cooperative research?
Well, it depends on the field of research, obviously. Membership of CERN would be largely irrelevant to astrophysics applications. In terms of success at the European level, I haven't looked at absolute figures, but my impression is we do pretty well. Eukarya would know better than I would. But we punch above our weight, and we've been leaders and participants in many EU-funded collaborations. And in fact, the fact that we are a fundamental basic research organization is a great advantage there, because that's the sort of thing that the ERC, for example, is looking for. So, yeah. I think Jim...
We're going to take 2 more questions, one here, please, and then I think Ben Joe has a question.
Jim has a question.
Jim, you have a question. We'll take 3 more.
Okay.
Sorry, excellent talk. I was just wondering, what do you think, is there any future for Dunsink itself?
Well, of course there's a future for Dunsink. What there is not a future for is Dunsink as an observational facility, but as a historically important building, as the first purpose-built research institute, in a sense, in Ireland, as a location where you can do public outreach, as a location where you can base research people and be inspired by the history. Yes, of course there's a future. And it's not unique. You see exactly the same thing with observatories all over Europe. Old observatories are, in a sense, monuments. They're not really ideal as research facilities, but on the other hand, they have a very important role because of their historical significance and as public outreach facilities.
Do you have a question?
Yeah, thanks very much for the lecture. That was very interesting. I won't ask you about cosmic physics, but I will ask you about something I understand. When De Valera came forward with the proposal for the Institute, was there much opposition to it at the time? Was there a belief that maybe this was a bit of a vanity project by him, as you described him, somebody who mightn't have been a very successful mathematician?
Well, I think he was a competent mathematician. I don't think he would ever have been a great mathematician, but his interest in mathematics was definitely real. Yes, you can read the Doyle record, and of course, Fingale attacked it viciously at the time, but Dev's status was such that he was able to get it through. And I think it wasn't a vanity project. I think he genuinely felt that he was horrified, I'm sure, at what he saw happening in Europe with the rise of fascism. He did want to do something. He did have a deep admiration for Hamilton and Ireland's tradition in scholarship. He wanted to revive that. He thought it was important for Ireland's standing in the world that we have such distinguished scholars working in Ireland. And he was a complex man. He never did anything for one reason. if you look at the way the Act is structured, it seems clear to me that one of his intentions was to build a bridge between UCD, well, the National University and Trinity, and basically provide a neutral forum in the Institute where they could talk to each other, which they weren't doing at the time. So he never did anything for one reason. There were many reasons for it.
And our final question. Do you still have a question?
It was just a curiosity. I recall, if I recall correctly, the School of Cosmic Physics was early mover in understanding climate change. And they were.
Yeah. Well,
I wonder which of the professors was involved in that.
Pollock gave one of the interesting things that Edmund Taylor Whittaker did was he advised De Valera that one of the conditions he should write into the Act is that every school of the Institute has to give at least one public lecture a year. And Pollock gave an early lecture on climate change where he said that the Irish climate was getting warmer. Now, I don't think he would at that time have linked it to anthropogenic greenhouse gases, but he was certainly open to the idea that climate was not a fixed thing, that it was changing, and the record even at that point showed that Ireland was definitely warming up a bit. And he went as far as to say that in the future you might be able to grow bananas in Dublin. Or at least that was the way it was reported in the evening papers. Yeah.
Thank you very much. So it's a very apt topic on which to end because clearly the climate is changing, and one of the areas of research that the school is working in now is monitoring ocean change, particularly in the Northeast Atlantic, which is critically important for us in Ireland here. What happens in the Atlantic is extremely important.
Yeah.
So I think we'll close. It's 8:30, so I just want to thank everybody for coming. Thank you so much for your engagement. And I want to thank Luke for a really, really informative and a really, really interesting evening. So thank you.